Heat loss in a blast furnace is not just a thermal issue, it's a cost issue. We must cool the furnace enough to protect it, but not so much that we waste coke and reduce efficiency. So as you can go through this slide, this is the core contradiction of the furnace operation. Hardware survival versus process efficiency. So if cooling is not balanced properly, the coke penalty can become very high. And once we could not able to balance this, economics never match and cost of hot metal will be not optimum to do a competitive business. So coming to our next slide, where most heat loss is concentrated in the lower furnace, especially the Bosch, Bailey and the Tuer zone. That is why these areas deserve our maximum attention during design and operation. At the same time, the gadgets, the probing equipment, the attentive AI ML resources are available across these segments need a lot of attention as for its health, its execution, its feedback, and continuously reviewing of it in terms of calibration and health is to be executed in order to work accurately. So coming to our next slide, which is basically on a stable skull and which is really art and skill by a operator to breeze their probing equipment outcome with the chemistry of the furnace and this peeling stability. So a stable skull act like a natural insulation inside the furnace. If the cooling system can hold that skull properly, it protects the shell and sends more heat back into the process. So this is a very vital and important one. Coming to the cooling architecture, we should not be judged only by the first cost. The better question is which system gives stronger skull anchoring and lower long-term fuel consumption. So based on these, we have to establish the further roadmap. Coming to maintenance, this is maintenance also changes the economics completely. If repair takes day and require blow down, uptime suffers badly. Faster external repair gives a major operating advantage than other type of repair. So always keep in mind these lines. So operating trend is clear. Lower heat loss is linked with lower coke rate. There is no doubt about it. Good thermal design is not theory alone. It shows up directly in the furnace performance also. So we must have to breeze the performance outcome with the theory and then we have to correlate the things. The final lesson is simple. Do not fall into capex trap. A furnace should be designed for lifetime thermal efficiency, a skull retention, and better margin. So stop treating cooling as shell protection alone. Start managing it as a driver of furnace economics.